Hi everyone, today we're going to look at LeetCode problem called Majority Element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than half of n times. You may assume that the majority element always exists in the array. For example, when nums equals 3, 2, 3, the output should be 3 because 3 appears more than half of the total times. The same goes for the nums 2, 2, 1, 1, 1, 2, 2, and the result should be 2 in this case. There are a lot of ways to solve the problem, but the method I will introduce today will be the most efficient one. Its time complexity is O of n and space complexity is O of 1. It's called the Boyer-Moore majority voting algorithm. The code of the algorithm is pretty easy, although it's not that easy to prove its correctness. Unlike before, I will show the code first, walk through the process, and explain it afterwards. I think you will better understand the algorithm this way. Here is the code. First, we create two variables, count and candidate. The initial value of count is 0. The initial value of candidate could be any, and we use -1 here. Then we iterate through the nums array, and in each iteration we decide our operation based on the current condition. We have three choices. If count is equal to 0, then we assign num to candidate and reset count to 1. If candidate is equal to num, we increase count by 1. Otherwise, we decrease count by 1. And in the end, we just return candidates is the majority number we want to find. To really see how the algorithm works, let's suppose the nums array is 1, 3, 3, 2, and 3. And let's go through the process step by step. I've just listed a table here, which includes the current iteration, the current number, and the value of count and candidates at the end of each iteration. The value of iteration and num are obvious, so I've just written them here beforehand. We should focus on count and candidate. So let's go through the process and see what happens in each iteration. In the first iteration, because count is still the initialized number 0, so we come to the first clause, which means we should set candidate to the value of the current number 1, and we should set count to 1. In the second iteration, count is not 0 anymore, and the candidate is not equal to num because candidate is 1, the current number is 3, so we should decrease count by 1. Let's set count to 0, and the candidate remains to be 1. In the third iteration, count is 0, so we should come back to the first clause here. We should set candidate to the current number 3 and the count to 1. In the fourth iteration, count is not 0, and the candidate is 3, num is 2, so this clause doesn't hold. We should decrease count by 1, so we should set count to 0, and the candidate remains to be 3. In the last iteration, count is 0, so we come back to the first clause, which means we should set candidate to the current number 3, and we should set count to be 1. So in the end, as you can see, the final value of candidate is 3, which means 3 is the majority number. That is correct. The intuition behind the algorithm is that count can be taken as a vote for candidates. When we encounter a different value from candidates, we decrease the votes. When we encounter the same value as candidates, we increase the votes. Some people find it hard to understand the intuition. Maybe the following two rules can help you better understand it. The first one. If candidate is not the majority number, the majority number along with all other different numbers will vote against candidates. So candidate is doomed to step down. If candidate is the majority number, all the other majority number will vote in favor of it. Since the majority number appears more than half of the times, the majority number is bound to win. So as you can see, in the end, our winner is bound to be majority number, and the majority number is what we want. That's all. That's how we solve the majority elements Leetcode problem. Please click on the like button and subscribe to the channel if you find the video helpful. Thanks for watching. Bye.